like I stopped before, we stopped at thermal cracking. So quickly, let's continue with catalytic cracking before I move on. But any question on the thermal cracking?
No question, please.
Okay, so thank you. So for catalytic cracking, just as the name implies, it's simply the breaking down of heavy oils into lighter oils with the use of a catalyst. So in thermal cracking, the temperature was about 600 under high pressure. Then for catalytic cracking, is simply subjecting heavy oils to a temperature of about 500 under reduced pressure and in the presence of a catalyst. The catalyst in this case is usually natural clay. That is the catalyst. A natural clay is a catalyst involved. So natural clay. And this is a mixture of silicon oxide and aluminum oxide. So that is the catalyst involved for catalytic cracking. Just a minute, let me admit this person. Any question?
No.
Okay, so if that is taken, let's also look at a possible equation. Now for catalytic cracking, please note the product obtained.
Sorry, please.
Yes.
Why not check the formula for that aluminum oxide?
Okay. It's AL.
I think it should be Al2O3.
Yes, thank you. Thank you for that. Al2O3, yes. Thanks for that. So the product obtained for this catalytic cracking are usually alkanes and alkenes. And this product can be separated by fractional distillation. Which that is, you subject the product obtained to fractional distillation. And then the possible equation could be such as, let's see, C18H. Let me ask a simple question here. 16 times 2 times 18 will give us what, please? Can help us?
30. That's 36.
Okay, 36 plus 2 should be about 38. So this will be 38.
38.
And then when this is broken down, I would have C6. C6, H, 6 times 2 is 12. 12 plus 2, 14.
12 plus 2, 14.
Okay. Then plus C8.
C8.
H,
That's
16. This time around,
16.
Yeah, so this is
alkane group.
An alkane. This is an alkene. Then let's do a little mathematics as well to know what will be left, because they cannot give the student as maybe 2x and ask them to identify x.
Okay.
So in such a situation, so 6 plus 8 gives us what? 6 plus
8 is 14.
14. Let's take away that
14.
Let's take away that 14.
We have 4 left.
We have 4 left. So that would be C2. Put 2 in front of that. That there's no space out. I'm writing this here. Then let's also add 14 plus 16. That should give us
30.
30.
30.
Take away that 30 from 38. That should give us 8 left.
8.
Am I right? Then divide that 8 by 8.
Yes.
It should be 4. So this is what you will get. C2H4.
Okay, that's 18.
It's also an alkene as well, specifically an 18 molecule, 2 moles of 18. So this is a typical equation for catalytic cracking. Any question?
No.
Okay. And the last type of cracking is hydrocracking. Hydrocracking. The very common ones I want to just read now. Hydrocracking is very rare. You see how many questions coming out from that is, but let's just look at it. In hydrocracking, it involves hydrocarbons being passed. Just a minute.
Okay.
Hydrocarbon being passed through hydrogen. into the mixture. That means you pass hydrogen into the mixture of the hydrocarbon during the cracking process. Under conditions, and the only lower saturated alkanes are obtained. Only lower saturated alkanes are obtained. Any question?
No.
Okay, so in the absence of any question, let's now look at one more before I move on. Reforming. We just finished now with cracking. The next thing now is reforming. All these are SS1 aspect of organic chemistry. Yeah. So I know some persons are actually not looking forward to this. They are interested in all those SS2 and SS3 aspects of the organic chemistry. But it's important to build them from here, then before we move on to SS2 aspects. So for reforming is the opposite of cracking.
Yeah.
So cracking is simply breaking down heavy oils into lighter oils, and the essence of cracking is to get a higher quantity. You want to get more quantity of particular fraction of crude oil, which is of higher demand. That is the essence of cracking. But for reforming is to improve the quality. So what then is reforming? Reforming is simply the process involved. Are you with me?
Yeah.
Okay. In converting straight chain alkanes into branched chain alkanes. And this is done in the presence of a catalyst. Reforming is the process of converting straight chain alkanes into branched chain alkanes, usually in the presence of a catalyst. Like I said, the purpose of reforming is to improve the quality. So let the student know that reforming has to do with converting low-grade petrol into high-grade petrol. That is the essence of reforming. Converting low-grade petrol into high-grade petrol. So, having said that, let's look at differences between cracking and reforming. Cracking, reforming, that is in terms of differences, or you can say cracking versus reforming. So for cracking involves breaking large molecules of petroleum fraction into smaller molecules. That is cracking. Breaking large molecules of petroleum into smaller fractions, while reforming involves rearranging of atoms in the molecules of the petroleum fraction. Rearranging of molecules of atoms in the petroleum fraction, that is converting straight chain alkane or straight chain hydrocarbon into branched chain hydrocarbons. That is one difference between cracking and reforming. Any question to this?
No, you can go ahead.
Okay. Then again, another difference is that cracking is achieved thermally or catalytically, because we just mentioned types of cracking, which is catalytic cracking and thermal cracking. So you can achieve cracking either thermally or catalytically, while reforming is achieved by catalytic process. Reforming is achieved by catalytic process. So in reforming, you don't need HEAT in the case. What you just need is the presence of a catalyst. Then another is that cracking occurs at high temperature, while reforming occurs at low temperature. Cracking occurs at high temperature, reforming at low temperature. And lastly, cracking improves the quantity, while reforming improves quality of petrol. Any question, please?
No, please.
Okay.
Sorry, please, can you repeat the first one you said?
The first one is that cracking involves breaking down heavy oils or large hydrocarbons into smaller fractions. That is for cracking. While reforming has to do with rearranging of the molecules of atoms present. Or you can simply say converting straight chain hydrocarbons into branch chain hydrocarbons. Converting straight chain hydrocarbons into branch chain hydrocarbons. That is for reforming.
Okay, thank you.
Any question? Any question, please?
No, no question.
No, you can, no question.
No question. Thank you. Okay, if there's no question, let me ask this question. Was a question from Neko. Say, what does cracking of petroleum products means? What does cracking of petroleum products means? Someone can help us. What does cracking of petroleum product means?
It is the breaking down of higher molecular mass hydrocarbons into simpler ones by the
Okay.
use of heat or catalyst.
Okay, thank you very much. Okay, another one here is, why is cracking employed? Why is cracking employed? It's a NECO question. Now, this one was NECO, not why. Why is cracking employed? I give that as the last difference between cracking and reforming. Cracking is
To improve the quantity.
yes, to improve quantity of your hydrocarbon or the fraction of petrol. Yeah. So just like I remember, I was asking before, if I give you now a liter of petrol and a liter of kerosene, which one will you collect? Or let me say maybe 10 liters of kerosene and 10 liters of petrol, which one will you collect? I'm very sure everybody hearing me will go with the petrol, because we all know of what importance petrol is today. So because of that, the high demand of a particular fraction of your crude oil is what brings about, or that's what necessitated the essence of cracking, so that there will be a balance. So let's quickly look at, as we move on, octane number. We don't have time. Octane number or rating. That's the last aspect of this one. We'll now go to organic chemistry proper. Octane number or rating. So now for octane number or rating, it is the value. If you are writing, you can write octane number or rating is a value that indicates how smoothly. It is a value that indicates how smoothly a gasoline or petrol burns in engine of a vehicle. It is a value that indicates how smoothly a gasoline product or petrol burns in the engine of a vehicle. So note this, that octane number, a petrol with a high octane number rating is a high quality petrol. And how do you know the octane number is the presence of 2,2,4 methyl. Methyl what can help us?
Pentane.
Pentane, thank you. Now, if you do this 2,2,4 trimethylpentane, how many carbon atoms would that be in all?
8.
8. Okay, that's C8. H. Can you try? Maybe
That be 18.
okay, 2 times 8, that is 18 years. So this is actually your petrol. If you remember, I was doing the catalytic cracking. This is petrol. So 2,2,4 trimethylpentane is an isomer of octane. Hence we say octane number. So we say octane number rating. A petrol that has a higher value of this is a high grade petrol. Remember we said the reforming is simply the process of converting straight chain hydrocarbons into branch chain hydrocarbons. If I draw this structure out, it's going to be on the straight chain. Then this is a branch chain. So I am converting straight chain to branch chain, and in that process, I am improving the quality of the petrol. So that is what we call octane rating. So let the student know it's as simple as that. So in case they ask them what is octane number or octane rating, it's simply how smooth the value which determines how smoothly a gasoline product or petrol burns in vehicles. So like I said, now the rating is always compared with that of that is octane. We compare it to octane, that is 2,2,4 trimethyl pentane. A petrol with a high value of 2,2,4 trimethyl pentane gives a higher octane rating. Any question?
I'm okay.
Okay, so then a petrol with a lesser value of 2,2,4 trimethyl pentane will give a low quality petrol, and such petrol can result to knocking of engines. That's why you see sometimes some people buy fuel in their vehicles and you now see the car starts jerking. Probably it's as a result of bad fuel, which cannot be ruled out because of the low octane rating of the petrol. So let me round off by this set of questions, this aspect now. I have high petroleum products. Okay, let me give the question. Let me just write it out. We have higher petroleum fraction. This gives me petrol plus X. And this is Roman figure 1. Then I now have X plus Y. This is Roman figure 2. So who can answer this question now? What is X? What is the question here is identify X and Y. Identify X and Y. Can anyone try? Identify X and Y. Are you sitting there with me, or I'm thinking to myself now?
Yeah, there with you.
Okay, so please, okay, let's do it together. What is the molecular formula for petrol?
It's
C8, C8, H,
18.
H18. Okay, remember we said when we break down higher petroleum products, such as maybe diesel or such as kerosene, if you check the catalytic cracking I did, we used kerosene, and kerosene was broken down to petrol alongside with an alkene. Now they now made it easier for us that X plus Y will give me this compound. Are you with me? So if X and Y is giving me C3H6, that means my X is now what?
C2H6.
Are you sure? Alkene.
You wrote C2.
Is an alkene, not alkane. When you break
Okay,
down,
an alkane.
when you break down a higher petroleum fraction, it will give you petrol alongside with an alkene, ENE. An alkene.
Okay, but the number of carbons you drew are just 2.
Yes, C2.
Yes.
Okay, sorry. What I give you the wrong.
That's where the confusion.
Okay, C2H6. So an alkene is CnH2n. That's the general molecular formula. Yes, so you know. So that means.
So that should be a thing.
Yes, so that means this is C2H4.
H4.
So that means my.
Then
X,
Y should be hydrogen gas.
yes, so this is. So X is C2H4, Y is hydrogen gas. Then again, the question again could be, what is the step? What is Roman figure 1 and 2? What does one mean and what does two mean?
And one should be cracking.
One is cracking, yes, catalytic cracking or cracking. Then why two is what?
That should be addition reaction.
Okay, addition reaction, specifically hydrogenation.
Hydrogenation, yes.
Because you have added hydrogen. So in case the student come across this, let them know what that is all about. So if there's no question now, let us go to hydrocarbons. Hydrocarbons. This is now SS21. So hydrocarbons are compounds that what?
That contains hydrogen and carbon. Organic compounds with hydrogen and carbons.
Okay.
Only.
Okay, only. I remember back then when I was applying for this PPB job, and we went for interview, specifically the micro teaching section, and I was asked to teach. The topic I wrote on the board was organic chemistry, and the lecturers who happened to be the interviewers posted into laughter, and I was wondering why are they laughing. The response they gave me was that I wrote organic chemistry on the board, and organic chemistry is a broad topic or a subject or a course on its own in terms of in higher level. So when I'm coming to teach organic chemistry now, which aspect of organic chemistry am I teaching? So I should just be specific. So when you write organic chemistry on the board for the students, let them know that organic chemistry is not just all about. So hydrocarbons is just a fraction of organic chemistry. So, now, when we say hydrocarbons, like you said, I always tell my students to pronounce it by themselves. When they pronounce it, hydrocarbon, then I'll now ask them, how many elements are you saying? As you are saying it out now, you will tell me two, hydrogen and carbon. So which means hydrocarbons are organic compounds or compounds that contains hydrogen and carbon. Sometimes we tell you hydrogen and carbon only. Am I right?
Yes, yes.
Okay. So now we'll look at classification of hydrocarbons. My board is so big to manage it if you can see it. So hydrocarbons are grouped into two. We have
Aliphatic.
open chain hydrocarbons,
Okay.
or I say what? Aliphatic, just like you said,
Aliphatic.
or also acyclic hydrocarbons. While the second one is closed, if it's not open, it's closed, opposite. Closed chain, or what?
Aromatic.
Or cyclic hydrocarbons. You said aromatic, but I didn't want to mention aromatic. I'm coming there. You see where it falls into. So hydrocarbons are either open chain or aliphatic or alicyclic, or closed chain or cyclic hydrocarbons. Now, under this open chain hydrocarbons, they are grouped again into two, which are saturated and unsaturated hydrocarbons. Are you with me, please?
Yes.
You cannot see the board, so maybe you can hear my voice. Just continue from there. So when we say saturated hydrocarbons, now let me come back to this one. Now, it will either be cyclic or closed, and this cyclic or closed now can now be broken down again into two. Here we have the alicyclic and the aromatic, like you said. Any question?
No.
Any question? Can I continue?
Yes.
Okay. Under saturated hydrocarbon, these ones are hydrocarbon with carbon single bonds. They are single bonds, and they are broken down into just one category here, which is the alkanes, or we call it paraffins. The board is becoming, there's no space again as I move on. So, any question? Then for unsaturated now, unsaturated is divided into two. Alkenes, ENE, and alkynes, YNE. Let's focus on these ones I wrote now before I come back to this part. Now, alkanes have molecular formula of CnH2n plus 2. That is the general molecular formula for alkanes. CnH2n plus 2. Where my N is greater than or equal to 1. That means N starts from 1 for alkanes.
I'm sorry, someone's mic is really disturbing.
Let's see. I really don't know whose mic is that. Okay, I think it's better now. So for alkanes, like I said, it has CnH2n plus 2 as their general molecular formula, and N is greater than or equal to 1 for alkanes, ANE, which is also known as paraffins. While the unsaturated hydrocarbons, which are alkenes and alkynes, has their molecular formula of CnH2n, and the alkynes is CnH2n minus 2. Any question?
No, please.
Okay. Now for the alkenes, which is ENE, which happens to be unsaturated, and also alkynes, my N is greater than or equal to 2. That means N starts from 2 for alkenes. So I don't have anything like C starting from 1 for alkenes and alkynes. N starts from 2. Let the student know that. So there's nothing like methane or methine. No. Now, having said that, let's now come to alicyclic and aromatic hydrocarbon. I want to clean because there's no space anymore to write. So I will clean these aspects. I believe you have gotten these aspects, right? So let me clean this off now. And let's come back to these two. So I will break that one down. So that means I'm writing now, this is closed chain, or what? Or cyclic hydrocarbons. So this group of hydrocarbons now, like we said, is divided into two, alicyclic and aromatic. Now, under this alicyclic, they are now divided into three. Into three cycloalkanes. So we have cycloalkanes, cycloalkenes, and cycloalkynes. While aromatic is just benzene and benzene derivatives. Now, for the cyclo, we call them cyclo from the word cyclic. That means they are close, they are in a cyclic form, they are in a ring form. And the cycloalkanes has their general molecular formula of CnH2n. CnH2n. Cycloalkenes is CnH2n minus 2, and this is CnH2n minus 4. That is cycloalkynes. Cycloalkanes, CnH2n, CnH2n minus 2, CnH2n minus 4. So let's take, for example, I have cyclopentane. Are you with me? Are you with me, please? Madam Esther, are you there?
Yes, I'm here.
Okay. So for cyclopentane, since the general molecular formula is CnH2n, pentane has how many carbon atoms? Pent. I think that should be 5. So that means cyclopentane will be having molecular formula of C5H10. Because we said it is cyclopentane. Cyclopentane. Since it is 5 carbon atom and it's a cyclic compound, so we draw it in a ring form like this. 1, 2, 3, 4. So it forms like this. 1, 2, 3, 4, 5. The carbon atoms or hydrogen atom are 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It begins with cyclo because it's in a ring form. It ends with ANE because the carbon atom are separated by just a single bond, one line. So that's for cyclopentane, which is an example of a closed chain hydrocarbon or a cyclic compound or a cyclic hydrocarbon. Then if I go by another example here, which is now cyclopentene, ENE, this should have C5, H2 times 5 is 10, 10 minus 2, 8. So C5H8. That is what we'll get for this. Then, in terms of the structure, it is similar to this, just that now the hydrogen atom has reduced from 10 to 8. So I'll remove one hydrogen from here, remove from here, and introduce my double bond. So it will form like this. This is hydrogen with another bond. So that is how it will look like for cyclopentene. Then another example now, maybe cyclopentine. That will be C5H, 2 times 5, 10, 10 minus 4, 6. So I'm removing 4 hydrogen completely. I remove these 2 from here, initially 2 from here, and introduce the triple bond. So this is how it will look like. Why these ones are my hydrogen atom. So this is the these are the classifications of hydrocarbons. Any question? I'm running out of time. I have less than 6 minutes to go. Maybe we can come back again. So come and start with homologous series, functional group, and then IUPAC nomenclature. Any question? In the absence of any question, I think I will round up this section now so that we can hook up the next 10 minutes to come and continue with homologous series. So next is homologous series. But I will stop here. At this point, I want to shut down this second section. Any question before I shut this down?
No, no question.
Okay, so I will shut this down now so that we can come back and just look at the homologous series and functional group and IUPAC nomenclature.